Alright, this is Mr. Gillum, and today what we're going to learn how to do is multiply fractions. Alright, and I've got a few visual aids that I think might help a little bit for those of us that have always had a hard time with this. Alright, now multiplication and what we've talked about with whiteboard warm-up is just another form of addition. Alright, and basically here's how it works. If I have 3/8 times 3, 3/8 times 3. What I'm saying is I have 3/8 three times. So I'm going to use blue here. I'm going to start with my initial 3/8, this much of the circle. Okay. And what I'm going to do is I'm going to add another 3/8 to it. Okay, so 3 more of these guys on there. And another 3/8 on top of that. Well, as you can see, I run out of space here and I need one more chunk on top of that. So total, if I had 3/8 times 3, I would have 1, 2, 3, 3/8. So total I have 9/8. Or you could think of it as 3/8 plus 3/8 plus 3/8 equals 9/8. Okay, however you want to think about it. Now there's a trick to these multiplication facts. Okay, if I multiply 3/8 times 3/1, there's no cross multiplying being done at all. I'm literally just multiplying straight across the fraction. 3 times 3 is 9. 8 times 1 is 8. You do need to reduce your fractions, but as you can see from the visual, multiplication is just as simple as addition. Take a look at another one here. This time, this chart represents 2 of, we have 1, 2, and 1, 2, 1, 2, 3, 4, 5, and 2/5. 2 and 2/5 times 2. That's what we have. 2 and 2/5 times 2. Well, 2 and 2/5 2 times, we can just add together, make 4 and 4/5, or we can say, let's change this to a fraction. 5 times 2 is 10, plus 2 is 12 over 5. If you forgot how to do that trick, you're doing 5 times 2 plus 2, 12/5. 12/5 times 2 equals 24/5. Once again, I'm just multiplying straight across every single time. Okay? So let's take a look at some more practice here. I'm going to get really good at these. Think of 1/2. If I wanted to know what half of a half was, I would first start with a half. So we'll just cut this guy right here. This red part represents a half. However, I don't want just a half, I want half of a half. So I want half of the shaded part. So as you can see, if I divided this evenly into 4 equal parts, the part that is double shaded is actually 1/4 of the entire part. Or I could say, if I want to take 1/2 times 1/2, believe it or not, the number actually gets smaller. 1 times 1 equals 1, and 2 times 2 equals 4, 1/4. Either way you want to think about it is fine. Okay, that should give you a nice visual as far as how multiplication is actually working. If you multiply anything by a number less than 1, it actually does get smaller. If I wanted a half of 3/4, let's take a look here. This is a fun one to do. Let's do, that color's fine. Okay, a half of 3/4. So first of all, we got to find where 3/4 is. Let's just divide it into 4 parts, and 3/4 is this part, and including this part as well. There's 3/4. Now the tricky part, let's use this nice pink color. What I'm going to do is I need half of that. So I'm going to divide every single one of these into halves. Okay, and now as you can see, believe it or not, I have it divided into 8ths. And I want half of this part, half of that part, I want half of this part, I want half of this part. I got half of each part of the 3/4. So now each of these little segments here in this pink and brown, those are actually 1, 2, 3 out of a total now of 8. So it's going to be 3/8. Now, algebraically, or numerically, I should say, it works kind of the same way. I'm going to take 1/2 times 3/4, and it's going to equal 3/8. Multiply straight across. Sometimes I see students get confused about cross multiplying, which happens when you have an equal sign. These are not proportions. Okay, so don't cross multiply anything today. All right, so let's do a little practice. Now, I specifically picked these 3 examples because there's no shortcuts to these. You just have to do them the long way. All right, so let's just take a look here and find a good color to use. That one looks fine. When I'm multiplying straight across. 4 times 9 is 36. 5 times 7 is 35. You don't even have to change it to a mixed number. 36 over 35 is just fine. Okay? Let's go with the purple. 7/9 times 2/5. Once again, this is multiplication. It's not division, it's not addition. There's no common denominator. There's nothing crazy. All you have to do is multiply straight across. 7 times 2 is 14, and 9 times 5 is 45. There's nothing to reduce. I specifically picked these 3 problems because there's nothing to reduce on any of these first 3. I just want you to practice multiplying straight across and not getting confused about anything else. It's just really straightforward. That's all you have to do. Okay. Finally, 3/5 times 9/8. 3 times 9, 27, over 5 times 8, 40. Once again, there's nothing to reduce. Okay, I made sure of that on this first page. You can check to see if they reduce, and there's some tricks to reducing, but we're going to do that in just a second. Okay, now let's take a look here. This is going to be the really important page for you to pay attention to, because this is going to actually make this way easier for you, I think, or I hope. When I multiply, I'm still multiplying straight across, and it's just as an effective method. 4 times 9 is 36, over 8 times 7, 56. Now what I notice here is that I have an even number over an even number. So I know for sure they will reduce. Okay, so now I'm thinking, what number goes both into 36 and 56? Well, because they're both even, I know for sure that 2 is going to go into both of them. So I'm going to divide both of them by 2, and to reduce the form, 18 over 28. And once again, I notice they're both even, so I can reduce again, 9 over 14. After that, if I'm not sure if any numbers go into 9 and 14, the fastest way to find that is checking the factors of the littlest number. The 9 has a factor of 1, 3, or 9. That's all the factors. So if 1, 3, or 9 does not go into 14, I know it cannot reduce anymore. In this case, 1, 3, and 9, none of them go into 9, or none of them go into 14. So this is as good as it gets. Now, wouldn't it be nice to skip over all the middle work there, all the reducing, and in fact using smaller numbers? Well, we can do that. So what I'm going to do is I'm going to show you how to do that. What I'm going to do is, first I'm going to check to see above and below my fractions, is there anything to reduce? Does 4 and 8 reduce? I mean, it's going to be way easier to reduce 4 and 8 before I mess with 36 56ths. So I'm going to go ahead and reduce 4 eighths into 1/2 right away. And so my problem is now 1/2 times 9 sevenths. Okay, I would also look to reduce the 9 sevenths if I could. In this case, it doesn't reduce. So I'm just going to leave it as 9 sevenths. All right, so now I could say 1 times 9 is 9, and 2 times 7 is 14. So you bypass all the big numbers here that you had to mess with if you reduce first and then multiply second. So that's the first thing I want you to check for. And we're going to practice 2 more exactly like that, and I'll show you another trick on top of that that you should look for. All right, so once again, I'm going to look, and I'm going to go ahead and do it the long way first. 7 times 2 is 14, over 9 times 10 is 90, and I notice that both of them are even again. Well, if I can divide both of them by 2, 7 over 45 is what I come up with. Now, I know that 7 is a prime number, so I have 1 or 7, and I know 7 doesn't go into 45, so this is the reduced form. Now, that one didn't have near as many steps, but I promise it's still quicker to do it this way. Let's go with this. I'm going to look at the first fraction. I notice there's nothing to reduce. I'm going to leave it as 7/9. The second fraction, though, I see they're both even numbers. So what I'm going to do is I'm going to multiply by, I'm going to write the reduced form of this fraction, 1/5. In this case, 7 times 1 is 7, and 9 times 5 is 45. If you check to reduce, a lot of times there's nothing to reduce at the end. So you get the same answer either way, but I promise that this little shortcut is going to save a lot of time in the long run. Take a look at this last one, and once again, I'm going to go ahead and do it the long way, but as you can see, the numbers got a lot bigger. So I'm going to say 27 over 96. Oh man, it's going to be hard to find a number that goes both into 27 and 96. Luckily, I know that 3 goes into both of them. 3 goes into 27 9 times, and into 96, how many times? 32 times. So now I'm thinking, okay, I got my choices are 1, 3, or 9 that go into 9. Do any of those also go into 32? No, they don't. 9 over 32 is the best that I'm going to be able to do here. However, I'm lucky because I'm a math teacher and I know my multiplication facts really well. You might not know 27 and 96 reduces. So what I want you to do is I want you to reduce before you multiply. Let's look at this first fraction here. It says 3/12. I know 3 and 12 both share 3, so we could write this as 1/4 times. Now I wish something would reduce here with the 9/8, but unfortunately it does not this time. So my new problem is 1/4 times 9/8. I'm just going to say that's 9 over 32. So instead of having to type in a bunch of numbers into our calculator to try to reduce that and finally get the 9/32, I can just reduce it at the beginning and have a much easier problem to solve. The last little trick I want to show you before we're done is the double reducing. All right, so the first thing you should do is you should check to see above and below if you can reduce. Okay, let's just do it the long way first though. 36 over 24 multiplied straight across. Well, that changes into 18 over 12, 9 over 6, which is 3 over 2. Okay, 2 goes into this guy, 2 goes into this guy, 3 goes into this guy, and finally, after I've reduced a bunch of times, I finally have 3/2. Now, there's ways to do this better. Let's take a look here. The same trick we just did. Let's look at 4/8. Oh, I noticed that 4/8 is really 1/2. And I know 9/3, 9 divided by 3 is just 3. 1 times 3, or you could change it to 3 over 1 if you would like. It means the same thing as 3 over 2. So without all the reducing or all the stress, if I just reduce these fractions before I multiply, life is good. All right. Now, tricky. 18/9. I'm going to go ahead and cut straight to the rule on this one. 18/9 becomes 2. 2/12 becomes 1/6. 2 over 1 times 1 over 6 is 2 over 6, which equals 1/3. Now, this is a really, really important problem because I still had to reduce at the end here. And I just promised you that you wouldn't have to reduce. So now I'm going to show you the second thing to check for after you check to reduce first. I'm going to write the problem up here again, the original problem, 18/9 times 2/12. Once again, I am going to look to see if I can reduce above and below. So I'm going to change it to 2 times, and I'm going to go ahead and reduce this guy as well, 1/6. Okay, that's good. Now, although you can't cross multiply, what you can do is you can cross cancel. Because when I multiply, these things are going to end up on top of each other either way. It doesn't matter. So before I even mess with that, I'm going to look sideways. Is there anything this direction that I can reduce? Do a 2 and 6 have anything in common? Well, I know they do. A 2 has a 2 has a 2 in common one time, and a 6 has a 3 in common one time. So now when I'm multiplying, I just need to take 1 times 1 and 1 times 3. 1/3, which is the same answer I got before. So if you look to reduce initially, above and below, and then crossways, you will be guaranteed not to have to reduce your answer later. It's really, really nice. So I'm going to do the same thing again. I'm going to go ahead and look. Let's actually, just so we have another good example, I'm going to actually look to cross reduce first, even though I know that we can up and down reduce. Just for the sake, this guy would turn into a 4, this guy would turn into a 15. Is there anything to reduce here? Oh, well, 4 goes into 8 and 12, into 8 twice, and into 12 3 times. Now let's look above and below. There's a 15 and a 3. 3 goes into 3 once and into 15 5 times. 2 and 4 reduce. 2 goes into 2 once and into 4 twice. Now all I have left to do is 5 times 1 over 1 times 2. 5 over 2. And that's it. Now, we should probably get set in our ways as far as what to do first. So really, ideally, if you can, I would like you to reduce first, because that, in this case especially, it'll be a little quicker to reduce first above and below. These guys both have